I shall go talk, right? So here, what I was saying here is that this point, when x is 0, y is e to the power 0, anything to the power 0 is 1. So the point 0, 1 is a function that will always be on this graph. That's okay? So you can remember it like that, right? Remember this point here, when x is 1, when x is 0, y is 1, this is the graph. The graph never touches the x-axis. The x-axis is called an asymptote. Okay? What that means is that this function, e of x, right, is never equal to 0. Right? It will never be equal to 0. There is no x value that you could place in here that will give you a y value of 0. All right? So that's not possible. Then, if we draw the line y equal to x, and we reflect this, we will get a function that looks like this. If I reflect this in this line, I'll get this function here. And that function is what we call ln x. Okay? So e of x and y is equal to ln x are reflections of each other. It's not. Right? Right? Are reflections of each other. You got the broken thing on the LMS. On the LMS has everything broken down by module. But I went on to the LMS and everybody got in 2 weeks ago. Log in and see from my place. Log in, you will see both module 1, all the videos to module 1. Both module 2, check it and see. I show and I go, I see no activity. What everything there, you can use it for cool and thing as well. Go on it now. Go on it now. Right. So again, you can see it. It's next one for it. All right, nice. So as I was saying, right? We're gonna take a look at the functions, right? And all the indices rules, I just want you to note this, right? All indices rules apply to e of x, and all the log rules, which we'll do over in a little while, apply to ln x. All right. Huh? Right. So let's start with a very, 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 very simple example, right? In case it didn't work with us before. Let's say I gave you e to the x is equal to 5. How do we solve for x? Right? So in order to solve more questions like this, what we have to do is to take, you gotta remember, like if you have something like this, what you do? Take logs on both sides. So you'll take log 2 to the x is equal to log 5. Bring the x here, move across log 2 here. That's okay? We're going to do the same thing here. So instead of taking log, we're going to take ln on both sides. So we're going to take ln e to the x, right? For those who never saw this before, let me just give you a quick little thing. Ln x is really log to the base ex. We'll focus on this when we start logs, right? I'm just showing you this because I want you to be able to solve things like that. That's okay? So you take ln on both sides. What you'll do with the x? Bring the x in front, right? So you'll get x ln e is ln 5. Bring it across. Ln 5 ln e. Without going to calculator, what do you all think ln e is? Ln e is 1. Right? What's this here? If x is e, you'll get ln e to the base e. When these two are the same, the value is 1. Right? So your answer is x is equal to ln 5. That's okay? So if you see something like that, that's the way you solve it, right? Take ln on both sides and work it out. Right? Go take calculator and just work out ln 5. Yeah? Yeah. Coming up. Yeah, you could just cancel ln e 1. Right, for those who are doing pure privately, or like a drop off the form today, right? Pure office or anything. Solve for x there, pa. Solve for x here. Right? How it went? Ln on both sides. Same thing, ln on both sides. So you'll get ln e to the x plus 2 is 3. Bring x plus 2 in front. Right? Take ln on both sides, bring x plus 2 in front. Ln e is what? 1. So x is equal to ln 3 minus. How much is that? Right? You can leave it like that, but if you want to work it out, how much you get? Negative 0.9. Let's go again. Upside down again, true? How are we doing that? Make a substitution and fit it in 2A for Jack. Go ahead, add up. And I got have it one here for you. More, I want the yellow. Huh? I went past it, yeah, something with both of us. I'm gonna go to the one that's closer. Right, so Anaya said to let y equal Anya mean y equal to 2 to the x. And she also said that y squared is what? E to the what? 2x, right? So this equation becomes what? It becomes y squared minus 5y plus 6 is 0. All right, solve it quick. Sorry, ma'am. I get you. Got you. So when you solve the quadratic, what you got? 3 and 2?
Yeah.
And then y is really e to the x. So e to the x is 3. So x is ln 3. E to the x is 2. X is ln 2. Everybody okay with that? Are you okay with that? Let's go again. How are we doing number 4? All right, they're looking like yours. You follow number 3. About 4 easier. Yeah? Carry across the 6 and turn it into a quadratic. Right? But you had to make a substitution again, right? So how can I rewrite this? E to the x, what does the minus indicate again? 1 over, right? And then bring across the 6. What's the substitution you can make? Well, we can let y equal to e to the x, yeah? And then get rid of the fraction. Try it. See how it looks. You're did the same one. Get patience. I give you one line this last one. Solve it quick. You're done? Right, so Olia, these questions are exactly like what we did last day, right? It's just you're working with E now, right? So I have y plus 1 on y minus 6. Online, you're getting through? What do I do now with fraction? Multiply everything by what? Y. Multiply everything by y, right? Y squared plus 1 minus 6y. So we have a quadratic, right? What you all got? Y is how much? No solution?
Yes.
It should work out.
So minus
Huh? No, that's okay. It's now whole number. Give me the decimal now. 0.17
and 5.8.
and 5.83. Yeah, that can happen. You can get values like that. Can you get a negative value? Look back at your graph. Is there a solution for x if it's negative? What's your graph? Is your graph? Could your graph go on negative side? You sure? No, a negative y value. And your graph looks like this. So there is no solution in negative y part. So if you get a negative here, it means no solution. Okay? Your E of x can never be negative. Okay? Just like next one. Right? What you said here, E of x is equal to 0.17. So x is equal to ln 0.17. I'll just leave it. I didn't take it in met and know the answer. I see all the work is out. What's ln of 0.17? It's negative 1 point and ln 5 point. 1 point. 1.7. And most times it's okay to leave your answer in long. Right? Let's go again. I want to change it to long, right? Try that in. E to the x plus 1 is 5e to the square. So for x, right? Right. It was looking for. What we gonna do earlier? Joseph, any ideas? No. Joseph, anything? No? No ideas? Yeah, let me hear. So you're going to take ln on both sides, right? So you'll get ln e, ln 5 e to the. We have a little problem there, nine. But what happened here? I can bring it up. X plus 1 ln e, right? I have a little problem here, that's 5. Can you bring 5 outside? Nope. And this is multiplication. So you have to use it, you have to break it up first as multiplication. So it will be ln 5 plus ln e. Right? So the problem is the 5. Right? The problem is the 5 there. You can't take the power because the power is over e alone. So you can't take the power and use power rule and bring it in front. Can't do that. Problem is the 5. Now you can bring the 2x minus 3 in front. Right, Adam? Try it out now. Let's see what happens. Right, so hopefully you recognize or you remember that ln e is 1. So you will write x plus 1 here. Here is ln 5. And then you bring down the 2x minus 3 ln e. We know ln e is 1. So we have x plus 1 is ln 5 plus 2x minus 3. Then do your usual thing. Bring the x on one side. And bring the numbers on the next side. So I have minus x is equal to ln 5 minus 4. X is equal to minus ln 5 minus 4. How much is that? How much is that?
Yeah.
Huh? Tell me now. Okay. How much? And you apply the minus, right?
Yeah.
2.39. Who is doing pure applied and physics? And the pure applied that applies it?
I mean,
What are you doing? Very fucking man. I was too long for the run. I will swag and undo it. I will double up with the class, my class, and 2 after. The big after, I will double up. I didn't want to keep volume. Are you okay with this? So that's the way we solve questions like this. Only thing I want you to pay attention to is here, right? This is a product and we have to split it first. That's okay? All right. Next, head up log rules. Let's go over log rules. As I said, the log rules will apply to learn as well. Head up log rules.
Yeah.
All right, next, head up log rules, right? So now we focus on logs. You know, I can make all the prove all these log rules. Prove the rules. Oh, they get two, but I'll get one for true. All right, so we had to remember the log rules, right? But before we do the log rules, Narayan, we had to make sure that we could convert from, oh yes, there's one new log rule, right? We had to convert from exponential form to log form. So if I give you something like this, a to the x is equal to a to the x is equal to p, right? How do we convert again? How do we convert? It'll be log to the base a of b is equal to x. That's okay? So you bring down the a, carry across the b, carry across the x. Everybody okay with that? Yeah? So you have to remember how to convert from one to the next. So for example, if I gave you 3 squared is 9. In terms of logs, what will that be? That would be log to the base of 9 is equal to 2. Right? So we have to remember how to go from one to the next. Okay? Now, let's look at the rules, right? All right, any rules here, right? You write it in your book like no. I don't want to rub it off. So rule number 1, log to the base a of a is what? 1. All these rules could come from here. You could write the index in line and then come up with the rule. Right? What about log a to the 1? What's that? Next, what about log a to the m to the power n? What will that be? Log to the base of m to the power n. What will that be? Bring the n in front, right? N log to the base a of m. Online, are they okay? Let's see. Let's take up the show of terms. The drive in those guys. What is this here earlier? Log to the base a m plus log to the base a n. What you do? Addition you multiply, right? So it will be log to the base a of m n. All right? And then log to the base a of m minus log to the base a of n. That will be log to the base a of m divided by m. Right? So if you remember, right? Only way that we could use these rules is if we have them to the same base. Right? What happens if it's not to the same base? We have to do a change of base. Right? There's a way to change base. Okay? So how do I change log a to the m to the base c, let's say? Right? Real simple. Just write log base c here, log to the base c here. Right? Write the new base and put the whole number, whole base. Pardon me? No. What's right up there now? I'll put the example up here. I'll tell you all the rules here now. Yeah, it is base C, so you can put from the base A to the base C. All right, it's here for you now, right? Not here for you, right? And where you go and tell them what all you can see on the board, and so they want to help them out. Right, so you put, if you want to convert from the base A to the base C, you write log C here, and the old base goes here. Sorry, the old number goes here, and the old base goes here. So for example, if I want to take log 5, 10, and I want to convert to the base 10, right? All I have to do is this. Put log 10 here, log 10 here, whole number, whole base. Right? Let's do my favor now. Go take only Casio people, right? Go to your calculator, work out this, and then work out this. Tell me what you get. Can make sure. At log 5, 10, now we'll have log 10, 5. But what's wrong? Same thing? Yeah. Same thing. Okay. Right. Yeah. Kita bigyan sila. Ikaw niya, isa. Instruction niya. Tama. Everybody okay with that? So all I want you to do, go take calculator and just check and make sure they are the same. So if you see a question now and they're not in the same base, change the base. All right. Normally it is changed on the bigger base to the smaller. Right? But it don't really matter. It'll work out. Right. Before we move on, we have to prove this. How are we doing that? How are we proving that? Take a minute. See what you come up with. Yeah, try this now. Trial proof here. Right? So here's how we can prove this, right? Let's say y is equal to log m to the base e. Can you convert this to exponential form? Yeah? And then after you convert to exponential form, right? Instead of converting it back log to the base a, introduce log to the base c. What that means is like take log to the base c on both sides and see what happens. So convert to exponential, and then after you convert to the exponential form, take log to the base c on both sides, and let's see how it simplifies out. Try it and see. Just follow those 2 steps. See what will happen. So if you convert this to the exponential form, it becomes what? It will become a to the y is equal to m, right? But I want to introduce this log to the base c thing here, right? So let's take log to the base c on both sides. So I will end up with log to the base c of a to the y is log to the base c of m. So I'm taking log to the base c on both sides. Everybody okay with us? Then I can bring the y down here. I can bring the y here, right? So I'll get y log to the base c of a is log to the base c of m. And then I can move this here. So I'll get y is equal to log m to the base c log a to the base c. Right? But what was y equal to? Right? Y was equal to log to the base a of m. That's okay? Y was equal to log to the base a of m. And so I could take off this y and write log to the base a of m is equal to this. So if ever they ask you to prove it, that's what you do. Okay? Yeah. So after I convert to the exponential form, I take log c on both sides because I want to prove this. I want to prove that log to the base a of m is log to the base c of m. So I have to introduce this log c thing now. So I took log c on both sides. Then bring down the y, carry across this. And now y equal to this. But I also know y equal to this. So I create them. This equal to that. That's okay? Everybody clear now? Right? Let's go again. So now we're gonna try to solve log equations, right? So let's do a couple easy ones and then we try some harder ones. What is considered hard here is that you're doing the same rules, but instead of log 3 here and log 3 here, you'll have log 3 and log 5. All you have to do is just change the bits. All right? So let's do a few easy ones just to help you remember what to do, and then I'll leave the rules up, right? There is this. All right, so let's solve log, right? So we're taking a look at solving log equations. Please remember what I said earlier, right? Log rules follow the same thing. Okay? So if you see log or you see ln, using the same rules. Okay? And ln is what again? Log to the base e is what we call ln. Okay? So all these rules here apply for log. Even if you want to change the base, right? But so let's solve here. Let's start easy. Let me give you things that move. Let's start here. Log 2 to the x is 7. What to do? Supposed to be easy. What can do here? Right? So we have two things we can do. Some people would recognize that we could convert to exponential form one time. So you will get bring up the 2, carry across 7, make it equal to x. That's the answer. Or some people might introduce log 2 on this side. That's okay? Log 2 is 1, right? So I'm not changing the value in any way. And then I can bring 7 here. So I'll get log 2 to the x is equal to log 2 to the 7. And then when you have log on both sides, okay, drop the logs. X is 2 to the 7. Anyone can do it. Okay? Copy it down. I will go on to the next type, right? Convert to exponential form. No, not that. Except. Right, so as I said, you could choose any method you want, right? Huh? Well done. So this one I'm gonna convert to exponential form one time. So that's 2 to the 5 is 3x minus 1. 3x is, what is this here again? 32 minus 1, sorry, plus 1. 3x is 33, x is 11. Right here, we're going to do the same thing. Convert to exponential form. X squared is equal to 2x plus 3, x squared minus 2x minus 3 is 0. Right? And you'll get x's and minus 1. Right? Remember your graph. Please remember your graph. Can we find log of a, yeah, can we find log of a negative number? Check and see, right? If I put 3 in here, staying positive, minus 1 in here, staying positive. Okay? Yeah? Right? But let's just say this was negative 3. When I put negative 3 in there, this value becomes negative. And we can't find log of a negative number. That's okay? Try this here, please. One number 4. Log to the base 2 of x plus 1 minus log to the base 2 of. Try that tomorrow. Chain base, right? So that one kind of normal. What's the first rule we're going to use? Right? First one will be the rule number 5, right? And then it will look like the others. Right? Try 4 and 5. And we'll try a slightly harder one, right? All right. You all get through? Quite hard. Easy? All right. We just have one hard one to do, right? Someone else. So this will be log to the base 2 of x plus 1 over 3x plus 1 and 2. And then I'll convert to exponential form. I'll get x plus 1 over, it's 2 squared. So that'll be x plus 1 over 3x plus 1 is 4 and 1. Cross multiply. And then bring your x's together. I got x to be minus 3 and 11. All together? Yeah. Can it work? Minus 3 and 11. Will it work here? Will it work here? Check it for me now. It'll work here, but 3 by that minus 9 here, it'll work, right? So that's valid. So it's valid, right? Well, what do I do here? Change base, right? Normally what it is do is take the larger base and convert to the smaller base, right? It don't really matter, right? But I will take the larger base and convert to the base 2. So converting 4 to the base 2. So I have to divide 2, 4 here. All right? Minus log to the base 2 of x plus 1 is equal to 1. Please don't convert both of them. Huh? One will stay to the base 2 and convert 4 to the base 2. So this is log to the base 2 of 2x plus 2 all over. This is 4. 2 squared, the square will come in front, right? Minus log to the base 2 of x plus 1 is equal to 1. This value here 2. So I am going to multiply everything by 2 because I don't want this, right? So I'm multiplying everything by 2. Log to the base 2 of 2x plus 2 minus 2 log to the base 2 x plus 1 equal to 2. So I'm multiplying every single thing by 2 to remove the logs. Now I'll get log to the base 2. What do I do with it? 2. Bring it in front, right? I can't apply the rules as yet, right? Because it must be coefficients of 1, coefficients of 1. So because of that 2, I'm bringing it here. 79. Come on, where you get lost? You're looking like you're now logging in there. Yeah. How come the? Yes, log 2, 4. But while I wasn't watching, instead of writing 4, I write 2 squared. Huh? So I would end up with 2 underneath here. Huh? I make it harder. Okay, so what you did here with log 2, 4. Huh? What you did? Yeah, you had log 4 here, yeah. This whole thing is log 4. I'm coming to watch it that's now, right? Right, so this is log to the base 2. That would be 2x plus 2 over x plus 1 squared is equal to 2. How about? Good. And then convert to exponential form, tell me. Will I get lost?
Yeah.
Will I get lost?
Yeah.
Let me start over. Right, problem here is what? They are not to the same base, right? Not to the same base. So I convert to the same base. So that'll be log to the base 4 of 2x, sorry. Log to the base 2 of 2x plus 2 all over log to the base 2 of 4, sorry. Everybody okay with that? New base, whole number, whole base. Everybody okay with that? Minus log to the base 2 of x plus 1 is equal to 1. Right? Let's just come to the side here. What is log 2 to the 4? Log 2, 2 squared. 2 comes in front, I'll get log 2, which is 2. Everybody okay with that? So log of 4 to the base 2 is 2. So now I have log 2x plus 2 over 2 minus log 2 x plus 1, 1. I don't like this fraction. How do we get rid of fractions? Multiply everything by 2. So that'll be log to the base 2 of 2x plus 2 minus 2, because I'm multiplying everything by 2. Log to the base 2 of x plus 1 minus 1. Everybody okay with that? That's the one. Yeah, equal to 2. Sorry, that's not a battery dying there. Right, sorry. So I got 2 cancel here, I'll get 2 here, and I'll get 2 there. Everybody okay with that? Right. Although I have minus and same base, I cannot apply rule number 5 as yet. I have to move it 2. So it will become log 2x plus 2 minus log to the base 2 of x plus 1 squared is equal to 2. So I'm taking the 2 and putting it in power. Yeah? Next step is what? Now I can divide, right? Yeah? So I'll end up with log to the base 2 of 2x plus 2 over x plus 1 squared is equal to 2. Y'all okay with that? No? Why you get lost? Yeah? So you're okay with this step, right? So I took the 2 and I put it here. Now, same base minus sign, same base minus sign, I'm going to divide. Right? So I'm going to divide these two. Right? And we know that log 4 is 2, right? So how much is this here? How much is this? And that's 4. So we're going and convert to exponential form. Right? We're going to convert to exponential form, and we'll get 2 squared is equal to 2x plus 2 over x plus 1 squared. Everybody okay with that? Right? So this is 4 over 1. 2x by x plus 1 squared, cross multiply. Kind of long, right? Expand this out, you'll get 4 by x squared plus 2x plus 1. Expand this out, you'll get 4x squared plus 8x plus 4, and I'm bringing across everything one time. This is 6x plus 2 is 0. Right? Minus a half and minus 1. Right. Right, the minus 1 won't work, right? So the only valid solution is this. Right? Are you okay with that? Very long, yeah. A little bit long, but are you okay with that? Yeah. That's correct, right? Minus a half. All right, nice. Confused? But okay, it's a little bit long, right? So I'm gonna send one on the group for you to try again, right? Right, yeah, we'll stop there for today.